Assalamualaikum warahmatullahi wabarakatuh. So we are from group EE242-6F. We are going to present our experiments about voltage sag. So my name is NABILAH binti AHAMAD, and my next.
My name is Ahmad AZHARI bin AZMI.
And my name is akmal RASMAN.
Okay, today we will explain about our experiment in P1, which is a voltage sag. So in the figure 3.1, we need to make a fault at the phase A. So this is a figure in the phase A. The phase B will sag because the connection of delta to Y. Sekejap. Kau boleh cut kan?
Boleh.
Patah balik dekat yang 3.1 tu sekejap. Okay. This is
Kau bagi keyword tau. Cakap next tu masuk aku turun ke bawah.
keyword
Next.
Oh,
Okay.
next. Okay.
Okay.
Okay, this is okay, 1, 2, 3. This is our lab, which is at the primary transformer site, fault at phase A. So at the phase A, at the phase B, the phase B graph will be set. So next. So at the phase A and phase B there will be a few ripple because the delta to Y connection. Okay. Next, at the table 3.1, that's a magnitude at the voltage and magnitude angle at the primary transformer and secondary transformer. Next. So based of the result above, so we can calculate the percentage based on the voltage set. So based on that, next, we can make a graph of a voltage set versus resistance fault. So based on the graph above, we can conclude that the magnitude of voltage set increases when the resistance fault is increased. So next will be conduct the experiment where the fault at the phase A and phase B. So this is the graph at the chart at the primary transformer site. Next, so this is a secondary transformer site at for phase A, phase B, and phase C. So next, so for the primary transformer, magnitude, voltage, and phase angle on phase A and phase B at the primary is changed into a certain value as shown in above table. So at the secondary, there is a change in the phase C because magnitude and phase angle. So since is phase A and phase B to ground double LAG fault, the fault is considered unsymmetrical in all the three phases. From the waveform at the primary and secondary transformer above, it can be concluded that this type of E-sag, since two vectors have the same set magnitude and phase shift value. Okay, next.
As for discussion, a short duration reduction in RMS voltage is defined in the voltage sag concept, which may be induced by short circuit, overload, or electronic motor begin. This occurs when for 1/2 cycle to 1 minute, their RMS value decrease between 10 and 90% of the nominal voltage. As noted in the industrial section, this voltage sag always occur from the theory in power lines such as lightning or a dropping object. So switching off heavy loads or excessive loads that typically result in short circuit or system failure on the transmission distribution system. Voltage sags occur due to certain incidents. Thus, these were the instantaneous waveform of voltage at the primary and secondary side of the transformer. As shown in figure 2.2, 2.3 and 2.4, this was the natural states for the transformer in which no fault existed. Next, there are several factors that can affect the sag magnitude. For example, the distance to the fault, the impedance of the fault, the type of fault, the level of preset voltage, and the configuration of the system. So the formula that can be used as follows in the calculation, the percentage of voltage sag on phase E on the primary side of the transformer. This is the formula, which is voltage before fault minus voltage after fault divided by voltage before fault times with 100%. So in this experiment, it will reduce the magnitude voltage on phase when the 0.001 ohms to 1 ohms fault resistance is increased. Figure 3.3 shows a graph of voltage magnitude versus fault resistance. It indicates from the figure that the graph increased gradually, which is directly proportional as the resistance fault increase. According to the voltage sag versus resistance fault graph in figures 3.3, the higher the voltage sag, the higher the resistance. It can simply be concluded from the obtained graph that the resistance fault affects the voltage set percentage. Okay, next, in the transformer configuration, the fault was set for phase A and phase B. On the basis of the results shown in table 3.3, the peak voltage value will decrease when the fault occurred in phase A and phase B. We can see main causes of voltage sag at the end of this experiment, such as abrupt load increases, abrupt increases in source impedance, and loose connection. It is known as the sudden change in the voltage phase angle during voltage sag for this phase shift. The higher the change in phase shift, the higher the voltage sag would be. Phase shift also has one of the characteristics of sag. Okay, next.
Okay, so for the conclusion, at the end of this experiment, students had successfully constructed the circuit to perform the analysis on the voltage sag phenomenon. So students were able to understand that voltage sags are short duration reduction in RMS voltage because by short circuit, faults, and many more. So when the fault circuit is applied to the system, the voltage is dropped to a certain value. So in this experiment, we found that by increasing the resistance fault value in the block diagram, it also increased the percentage of voltage sag in the system. Next, students also be able to analyze the impact of voltage dip capacitor VDC to the system. It is observed that the magnitude of the voltage that occurs at the incoming supply is the same as the voltage that occurs at the supply to the load. Voltage dip capacitors are designed to maintain the switchgear control voltage during the voltage sag, effectively keeping the circuit connected. The stored electrical and magnetic energy is allowed to flow, supporting the mechanical inertia of the machinery. So when the power is restored after a short voltage dip, the circuit is still running at near synchronous speed. The inrush current will be small and the stress to the system is minimal. So the VDC provides an economic solution for users who need their equipment to comply with their standard for voltage sag immunity. As for the effect of voltage sag must be reduced to prevent the system from being faulty by implementing the UPS, constant voltage transformer, and many more ways. So last but not least, the objective in this experiment is to learn the effect of voltage sag to the primary and secondary transformer at the distribution system. It was achieved as well as able to perform the analysis the impact of voltage sag to the system. That's all for the lab PU1. Thank you.